The most important part of this module is to be able to solve word problems with decimals. As in the module with fractions, I am going to discuss several different examples of problems you will need to be able to solve. You may notice when looking at the problems that they are really similar to the fraction word problems discussed in that module. The reason for that is simply because fractions and decimals are really the same thing, just numbers expressed different ways. Truthfully, if you want to change the decimals into fractions and solve the problems that way, you could do that as well. In addition to discussing decimal word problems in this video, I also have another worksheet you can look at, along with the worked out answers, to aid in your understanding. Here's the first example. Tim's work week was divided up into 3 parts. He spends 0.3 of his week traveling to get to destinations, 0.5 of his week meeting with clients, and the rest of his work week on the internet doing work. If he spent 10 hours on the internet doing work, how many hours long was his work week? Feel free to pause this video, do the problem yourself, and then turn it back on again and watch me as I go through and do it. As with all story problems, there are different ways to go through and solve them. So just because I solve it one particular way doesn't mean that you need to solve it this same particular way, as long as you end up with the correct answer. If I was going to go through and solve this, I am looking at the information and noticing that I am given different types of information. In some of the information I am given, I am told the decimal portion of the time that he spent doing things, and in the other part of the information, I'm given the actual amount of time that he spent doing something. So the very first thing I want to do is figure out what decimal portion do I know that he worked on some things. Well, I know that he spent a total of 0.8 hours doing traveling or working with meeting with his clients. That means that there must be 2/10 or 0.2 of the time left, because 1 minus 0.8 is equal to 0.2. And that 0.2 has to equal the remaining 10 hours. So at this particular point, I can figure out the total number of hours that he worked several different ways. If 0.2 of the time he spent is equal to 10 hours, that would mean that half of that time, or 0.1, would be equal to 5 hours. Well, if I want to know the entire work week, there are 10 sets of 0.1 or 1/10 in an entire work week, which means I would need to multiply 5 hours by 10 to get a final answer of 50 hours. Another thing that I could do when I get to this particular point, if I know that 0.2 of his work week is 10 hours altogether, I know that there are 5 sets of 0.2 in the entire work week, because 0.2 times 5 gives me 1. So I could have just taken the 10 hours and multiply that by 5, and once again get 50 hours. Once again, there are all sorts of different ways of doing this. You may have done it a different way, and that is certainly fine as long as you have the correct answer. Practice problem number 2. Andy was working to put a new floor in his kitchen. He worked very hard in the morning and was able to install 7/10 of the floor. In the afternoon, he was only able to install 6/10 of what was left before leaving for the day. How much of the original floor did he still have left to install at the end of the day? Once again, you may want to turn this off, go through the problem yourself, and then turn this back on again. The key to this problem is to find out how much of the original floor he was able to install in the afternoon. It says that he installed 0.7 of the floor in the morning. That means that there was 0.3 of the floor left in the afternoon still to install. But he only installed 6/10 of what was left. So I need to find out what is 6/10 of 0.3. So I'm going to multiply 0.3 times 0.6, and if I do that, I get 0.18, which means that he installed 18 hundredths of the floor in the afternoon. If he installed 0.7 in the morning and 18 hundredths in the afternoon, I'm going to add those up, and altogether that day he installed 88 hundredths of the floor. Well, the entire floor would be represented by the number 1. So I want to subtract 1, subtract 0.88, and when I do that, I would get 12 hundredths. So at the end of the day, he still has to install 12 hundredths of the floor. Practice problem number 3. Caroline filled her gas tank and noticed that the odometer was 42,000.4 miles. The next time she filled it up, she put in 12 gallons, and the odometer was at 42,372.4 miles. Assuming she gets the same number of miles per gallon, how many miles can she travel before running out of gas if her tank actually holds 16 gallons? In order to solve this problem, the first thing I need to do is I need to figure out how many miles per gallon she gets. So you can see that I've done some math here and figured out that she went 372 miles on this tank of gas. If she put in 12 gallons, I need to divide that by 12. And if I divide 372 divided by 12, I get 31 miles per gallon. If the tank holds 16 gallons, then I need to multiply 31 times 16. So when I multiply 31 times 16, I get 496 miles, which is the answer to the problem. Practice problem number 4. A fish tank at a local aquarium can only be filled up to 9/10 of its capacity with water. The aquarium now contains 650 gallons and is 25 hundredths of the way full. How many gallons will be in the aquarium when it is 9/10 of the way filled? One way to solve this problem is to figure out how many gallons will be in the aquarium when it is filled all the way to the top. It says it now contains 650 gallons and is 0.25 of the way full. Well, this is one of those times I might say, well, I know 0.25 is the same as 1/4. So, if 650 gallons is 1/4 of the way filled to the top, I need to multiply 650 times 4 to figure out what it would be filled up all the way to the top. When I do that, I get 2,600. But I can only fill to 9/10 of its capacity. So I want to know, what is 9/10 of 2,600? So I'm going to multiply 2,600 times 0.9, and I'll get a final answer of 2,340 gallons. Word problem number 5. Kelly is trying to decide if she should join a company that rents DVDs. If she is a member, she pays $35 per month, plus $1 for every DVD rented. If she is a non-member, she pays $5.50 for every DVD rented. How many DVDs does she need to rent in a month so it is a better deal to be a member than a non-member? One way you could go through and solve this is you could set up a chart. So you see that I have 3 different columns here. According to the information, if Kelly has 1 rental, as a member she's going to pay $36, $35 for the fee, for the monthly fee plus the dollar. If she's a non-member, she would pay $5.50. 2 rentals means that she would pay $37 as a member, $11 as a non-member. I could continue with this and come up with the numbers. I'm not going to do all of them, but you can see as I put the numbers in. Let's say we get to the 7th rental. The 7th rental as a member means that she's going to pay $42, and a non-member would pay $38.50. The eighth rental, Kelly would pay $43, but the non-member would be paying $44. So, as long as Kelly is going to have 8 rentals, it would be better to be a member than a non-member. However, there is another way to go through and figure out the answer to this rather than going through and doing all that work. According to the information, a non-member pays $5.50 for every rental, and a member pays $1. That means that there's a difference of $4.50 every time that a video is rented. Well, we have this $35 monthly fee. So, how many sets of $4.50 are there in that $35? If you go through and do the math with that, you get 7.77, and it continues on, 7.7777. It's 7.7 with a line over the 7 times. Well, Kelly cannot rent 7.7 DVDs. That is the break-even point, which must mean that Kelly needs to rent those 8 DVDs as shown this particular way in order for it to be a better deal to be a member. As with most of the other videos with this course, there is a 5-question quick check that you can do after this video to check your understanding. If you do well on it, you may be ready to take the assessment on this module. If you want additional practice problems to do before taking the assessment, you can find practice problem worksheets along with the answers in this module as well. Please feel free to contact me if I can be of assistance in any way. Thank you.